The learning goal for this video is to solve systems of equations by graphing. Remember that solving a system of equations, you are trying to find the point or points that satisfy both equations, the points where both functions intercept or where they meet. In grade 10, you would have solved linear systems using 3 different methods. The first method was by graphing, the second method was by substitution, and the third method was by using elimination. And you would have found that the lines met one time, no times, or an infinite number of times. In grade 11, we are going to solve a system of equations where one is a line and the other one is a quadratic. And I want you to think about the number of times a linear function and a quadratic function can meet. To solve systems of equations with a line and a quadratic, there are 2 different methods we are going to use. The first method in this video is graphing, and there will be another method on using substitution to solve. The steps to solving by graphing is to rearrange each equation into the necessary form. So for a line, it would be the y equals mx plus b form, and then use the methods to graph. So you would start on the b value, the y-intercept, and then use the rise and the run, which is your slope, to plot the other points. To graph a parabola, rearrange the equation into vertex form, plot your vertex, and then use the step pattern. And then you will find if and where the 2 functions meet. And then it is always good to check your results by substituting into the left side and the right side of each equation. Just a note, we did talk about another way to graph a parabola, so keep that way in the back of your mind. Using the vertex and the step pattern is the most common way, but if it is in factored form, you might want to use the x-intercepts and the idea of symmetry to graph that parabola. So in the example we are going to do, we are asked to solve the following system by graphing. We're given a quadratic function and a linear function. So first we will graph the line. We notice that it's already in the form y equals mx plus b. M is the coefficient in front of the x. So here it's 1, because that's 1x. And I like to think of slope as a fraction. So I'm going to write that as 1 over 1, because the top number is my rise and the bottom number is my run. The b value is the y-intercept, and here it's 4. So the coordinate is 0, 4. So now I am going to take my y-intercept, plot it on my y-axis. So 0, 4 is right here. And then I'm going to use my rise and run to find my other point. So I'm going to go up 1 over 1, and I will have a point here. And then I'll go up 1 over 1 and have another point. Up 1 over 1, up 1 over 1. It is hard to graph points accurately on this app, but you can see roughly where I've put the points and that they form a straight line. So now I will take, or you should take a ruler if you're on paper, draw a nice straight line with arrows at the end, and I'm going to label. And now I'm going to graph the quadratic. So here it is in standard form. I am going to complete the square to put this into vertex form. So to do that, I need to look at the a value to see if I need to factor from the first 2 terms. Here a is 1, so I actually do not need to factor out the a value. So what I'm going to do is just simply put brackets around the first 2 terms. X squared, 6x are going to be in brackets, and then plus 2 on the outside. Then I'm going to take the coefficient in front of the x, which is 6, divided by 2, and square that. So I'll get 3 squared, which is 9. And I'm going to add that in the brackets by adding 9 and then subtracting 9. So here you can see I've added in the brackets, and now I'm going to take the negative 9 outside of the brackets. Make sure you multiply it by the coefficient in front of the brackets, which is just 1. So I just get y equals x squared plus 6x plus the 9 plus 2, and then minus 9. So again, now I'm going to factor this trinomial. 2 numbers that add to 6 multiplied to 9 is 3 and 3, and then I'm going to simplify outside of the brackets. So I have just noticed that I made a mistake because this quadratic has the equation x squared plus 6x minus 2. So I'm going to change that to minus 2. So then when I simplify outside the brackets, I have minus 2 minus 9, which is negative 11. So therefore, my vertex is negative 3, negative 11. So I will plot that point in a minute on my grid, and then I will find the other points using the step pattern. So I take the numbers 1, 3, 5, 7, and I multiply each one by the a value, which is 1 in this case, because it was 1x squared. So my step pattern for this quadratic function is 1, 3, 5, 7. So I've plotted the vertex at negative 3, negative 11, and then I'm going to go 1 to the right, up 1, 1 to the left, up 1. And then from there, I'm going to go 1 to the right, but this time I'm going to go up 3. And then from the other point on the left, I'm going to go to the left and then up 3. And now I will do it one more time. The next step, 1 on the right, up 5, and 1 on the left, up 5. So that should be enough points. So now I will draw a parabola that goes through all of those points. Try to be as accurate as possible, especially because we are finding solutions. Again, this is hard for me to do on the app. So now I've graphed. I now need to find the point of intersection. I can see there is a point up here that the parabola and the line meet. And then if I continue this line, which I should have, I would find another point down here. So if your line is short like me, you should extend that line right through the graph. And then we can see there are actually 2 points of intersection. So my solution on paper, which is more accurate than the one on this app, is at 1 and 5. So there's a point of intersection here, so I've labeled 1, 5. And then the other one over here is at negative 6, and it's actually at negative 2. So again, not using a ruler affected where my point of intersection looks like, but yours, if you're using a paper and pencil, it should be at negative 6, negative 2. So finally, we are just going to check our 2 solutions. So the first one at negative 6, negative 2, I'm going to check into the line and into the parabola by substituting into the left side and the right side. So when I substitute in for my y, I get negative 2. And when I substitute in for x, I get negative 6 plus 4. So again, my left side's already simplified, my right side is negative 2. So it satisfies the line, that point satisfies the line. And now I will substitute that same point into the quadratic function. Again, my left side is my y value of negative 2, and my right side, I substitute in negative 6 for x. My left side is simplified. My right side, I now need to simplify, so I get 36 minus 36 minus 2, which simplifies to minus 2. So that point is satisfied on the line and the quadratic. So I know that this point, negative 6 and negative 2, is a point of intersection. So again, I am going to check my next solution, 1, 5, into my line. So I'm going to substitute in my left side, which is 5, and my right side, which is 1 plus 4. So 5 is equal to 5. So my point is satisfied on the line. And then finally, I'm going to check that point into the quadratic function. So my left side, again, is 5. My right side is 1 squared plus 6 times 1 minus 2. Simplify the right side to get 1 plus 6 minus 2, which equals 5. So that is satisfied. So now I have checked both points to see that they satisfy both equations.